In this video, I'd like to talk about a problem with Trominoes. Generally, there are two kinds of Trominoes, and I will use the second one today. The theorem to be proved is for any integer n more than or equal to 1, if any 1 square is removed from a 2 to the power of n times 2 to the power of n checkerboard, the remaining squares can be completely covered by L-shaped Trominoes. There is already one method on the textbook, so I'd like to prove it in another way. In the first step, I will prove by induction. I will use Pn to represent that using only L-shaped Trominoes can make up a bigger L-shaped polynomial whose size equals to 2 to the power of n. P1 is obviously true, and to be more specific, I also draw a picture of P2 here. And then I will show that if pk is true, then pk plus 1 is also true. Just like the way I used in P2, I make up a polynomial whose size equals to 2 to the power of k plus 1 with polynomials whose size equal to 2 to the power of k. Above all, we can prove that using only L-shaped Trominoes is able to make up bigger L-shaped polynomial whose size equals to 2 to the power of n. Then in the second step, to cover the remaining area. In this topic, we can remove any square. So I randomly choose one. This. Just like binary search, this step is kind of like a quadruple search. I will divide this checkerboard into 4 parts, and we can see that the removed square belongs to one of these parts, so I can cover the other 3 parts with L-shaped polynomials whose size equal to 2 to the power of n in this way. Just like a recursive function, I will repeat this procedure again and again until the last polynomial is a Tromino. Also, the polynomial size equals to 2. And then I have already covered the remaining area with Trominoes because the bigger L-shaped polynomials is made up with Trominoes.